So let's start off by looking at carbohydrates. Carbohydrates are digested partially in the mouth. They can only be absorbed when they are broken down to their smallest components, so monosaccharides, such as glucose only. Things like disaccharides, so lactose or galactose, or polysaccharides even, must be digested into their smaller components. This begins in the mouth under the influence of salivary amylase. So one of the first enzymes that is present in saliva is amylase, and it helps to start the digestion of starch in the mouth. But then we also have pancreatic amylase, which is a part of the pancreatic digestive juice, which helps to further break down the starch that's coming through in the duodenum as well. And so the end product that we get from starch digestion is disaccharides, which are the larger components that are not fully broken down. But then we also get these limit dextrins as well. And dextrins are basically these polymers of starchy components that are not fully digestible. And an interesting way to kind of relate dextrin to something you may also know is think about fiber. So if your doctor tells you that you need to ingest or bring more fiber into your diet, these are the kinds of substances that you're usually talking about. And we usually get limit dextrins from more complex carbohydrates, right? So think about the breakdown products, the byproducts when we break down more complex carbohydrates. These polymers that are left as a byproduct of breaking down those complex carbohydrates are thought to be beneficial in the diet because they're not fully digestible. They can kind of clean the digestive tract and help to decrease blood glucose as well because they're not digestible. So really important components of the fiber that we should be ingesting in our diet from those more complex carbohydrates. Okay, let's spend our last few minutes here talking about how carbohydrates are absorbed. And this should again be a review at this point as we talk about two mechanisms of transport that we should already know. So let's draw an epithelial cell here. So this is an epithelial cell. Here's our lumen of the GI tract, right? So that makes this the apical surface. And then down here, we've got the basolateral surface. And we can describe this region as having a brush border. So remember we said that we've got these microvilli, which creates this brush border, which is really important for increasing the surface area of the small intestine. So we're going to point that out here as well. Now on the apical surface, we have this sodium glucose transporter. So we've got this sodium glucose co-transporter that is moving sodium in passively. And then it's also moving glucose in actively. So we've got sodium moving in passively, and that is liberating the energy for glucose to move in according to its gradient. Okay. And then connecting that to what we know is happening on the basolateral membrane, we've got this sodium-potassium pump that is pumping sodium across the basolateral surface and into the blood So remember, we've got the bloodstream here that is underlying the connective tissue here. So underlying the epithelial surface, we've got the capillaries that are located in the loose connective tissue. And then that is where we're really absorbing our substances too. So we've got the sodium-potassium pump that's pumping sodium out and pumping potassium in. And that is creating the gradient So this is potassium being pumped in this direction, and then sodium being pumped in that direction. Let's make this an arrow. Okay, and so that is facilitating the movement of glucose across the apical surface. And then on the basolateral surface, we've got facilitated diffusion that's bringing glucose across the basement membrane or the basolateral surface. So the sodium-potassium pump is creating the environment where sodium is in a lower concentration inside the cell, and so it can be moved passively across the apical membrane. And so glucose can kind of hitch a ride with the energy that's liberated here. And then across the basolateral surface, we've got facilitated diffusion that's moving glucose from an area of high concentration. So glucose is going to move like this to an area of low concentration using a co-transporter. Not a co-transporter, rather, just a transporter. So this is facilitated diffusion. We're going according to the gradient here. So this is also a passive process. And all we're needing is a transporter to bring that about, right? So we've got co-transport, facilitated diffusion, and active transport. And all three of these processes is what is bringing about the absorption of glucose from the lumen of the GI into the capillaries that are underneath the epithelial lining here.